Hello friends, this is Jagannath. Welcome back to our YouTube channel CNC Guru Tech Center. As we are learning about CNC shop mill and shop turn series, in this series we seen about how to do facing, how to do face milling, how to do pocket milling, how to do turning, how to do step turning, etc., etc., etc. And in this series we are getting very good responses from your side. So and you are asking a good questions also. So on the basis of that questions I am trying to create a different new videos, new solutions for you. So in today's session we will see about how to create a profile pocket milling. In yesterday's session we seen how to create standard pocket. What is meaning of standard pocket? Standard pocket is like we are creating circular pocket and we are creating rectangular or square pocket. That is a standard pocket because we are getting that standard design inbuilt in our programming language. But if I want to create a different type of geometry rather than this square and circular geometry, what should I do? This is the very interesting question. So people are asking this question. So on the basis of that question, I am trying to create you few things. In today's session, we will see how to create profile pocket milling. In short, we will create profile pocket milling. It's very easy concept. You just need to understand. But today's video is little bit lengthy, and more important thing is that before starting to this video, I wanted to request you please see full video. Don't skip any point, because of if you will skip any point, then that will be a bigger trouble for you. So see video in very careful manner on, and after if you will see the careful manner, then and then only you can create this type of cycle, or you can create this type of program in your machine. So we will directly go to our topic now. So before going to our direct topic, I want to request you that if you are new on my channel, kindly subscribe to my channel, and if you subscribe to my channel, I will get good motivation from you, and on the basis of that motivation I will try to give you this type of the solutions. Okay, so my session is that I wanted to create a circular, or I wanted to create a profile pocket milling. So for that, in shop mill concept, we are going about only shop mill concept. So don't be confused about G code milling and shop milling. So we are here for only shop milling series. So here in shop milling, I have another like I have a separate question, like how to create that program and all. So that also I will show you in this program. So first of all, I will go to new, and I will get two options, that is a shop mill and G code guide code. If you will press this option, directly your blank screen will open in front of you. In that screen you have to create your own program. But in, as I said you, in shop milling programming, I don't need to create a G code program. I don't need to give any type of G code to my machine. My machine will generate this her own type of the G codings. So I will show you how that G code get creates and how it works, etc., etc. I will show you in very detailed manner. Don't worry about it. It's very easiest concept, but we need to be carefully understand this. So I will press this shop mill soft key, and then I will press give name here. Whatever name you wanted to give, you can give. I will give profile pocketing. I will give profile pocket. This is my name. I will say okay. If I will say okay, this type of directly window open in front of you. So you should give input to this window, and on the basis of that input, your cycle will get generated. So first of all, first input is that what is measurement unit? That's the mm. Work offset G54. You have to take work offset. That meaning is that you should use the work offset only that which you already taken in your machine. How to take work offset? That description, that video already given in description box. So you just go through that description box, so you will understand how to give different type of the work offsets. So G54 is work offset, blank is a block, my block size is this. So now in front of you there is a one screen. This is my profile milling option. So I wanted to create this type of profile in my pocket milling programming. So as per this diagram, I need to create a raw material size for this cycle particularly. So x00, y00, x1, I will give 250 is my x1, 250 is my y size. What is this 250? 250 means from this 0 up to this axis, x will be 250, for y also it will be 250, because this program is going, this workpiece size is like 250 is the sufficient amount of the material for this workpiece. Yeah, so you need to give this workpiece amount. Then ZA, I don't have any type of face allowances on my machine, on my drawing, so I will give you Z0 here. ZI is the total thickness of my workpiece. My workpiece thickness is 20 mm. I will give minus 20. Whatever you wanted to give, whatever as per your raw material and your machining condition. PL is 17. I am doing VMC machining, so that's why this is a 17. XY plane selection. RP is a retraction. After every cycle or after this cycle, my tool will go to up to 50 mm. That is called as RP. SC is a safety distance. Yeah, here is the concept of G98 and G99 that we are using in FANUC or ISO programming concept. So if you are using G98, that is a RP. SC is, we are using R point, that is called as SC. We are using G99 for that maybe. So you just understand the difference between this programming and ISO type of programming. Machining time, this is a down milling. So down milling is like, this is like a climb milling we can say, and this is the most beneficial milling for this operation. Then retract position, that is the optimized retract option. Yeah, so I am selecting this optimized. If you will select 2 RP, it will go to, after every cycle it will go up to this RP, and this will increase your cycle time. If you have any safety problem or if you have any type of fixturing problem, that time you should use this RP option. Otherwise this optimized option is a good option for everybody. So I will say accept. This is my header. So as per this diagram, I need to generate a G code programming, right? No, here we no need to give any type of G code programming. We will create this as it is diagram in my this cycle. So be careful, just understand very carefully. This is the diagram and I will create this diagram. How will I will create this diagram? So first of all, I will go to contour mill option. Once I will press this contour mill option, many options will get open in front of me. These are the sub option of this contour milling. So first of all, I will press this new contour option. In this new contour option, I will give one name. So I will give here name like profile. You can give any name. That name should be like a understandable name. You can give any name. So I am giving just a profile name and I am saying okay, accept. After accepting, directly this type of the screen in front will open in front of me. This type of screen will appear in front of me. This is like a AutoCAD screen. This is a very basic screen of the AutoCAD. You can say for your understanding purpose only. So I should give this diagrams input in this screen. So first of all, asking X and Y, starting point of my profile. So as per this profile, what is starting point? What is starting point as per profile? That is P2 is starting point. So what is the P2 distance? X along X and along Y axis. Along X axis, P2 is 75. Along Y axis, again P2 is 75. Understanding? This is my P2 and I am giving this type of the information for my P2. So this is my first starting point. So I will again press accept. Once I will press accept, this my P2 point will get stationed somewhere in my this page, this my graph. Okay, after that I need to give another point, that is P3 point. What is P3 point? So I need to see what is P3 point. I need to see that coordinate and I will, and how what is the shape of that, how it's the looks like. It's a rectangular, it's a straight line, it's vertical line, it's horizontal line, or it's a diagonal line, or it's a circular arc. So we need to decide, and on the basis of this diagram we should select any one input. So this fourth input is the correct input for this operation for creating this P3 arc. So I will go to this fourth option. In this fourth option, again I need to select my P3 arc is going from P2 to P3 is clockwise or anti-clockwise. As per diagram, it is a clockwise. So I will select this direction of rotation is should be clockwise. So I am just pressing this clockwise option. Second number is R. R means radius. What is the radius of this diagram? So the radius is 50 mm. Just check it. Radius is 50 mm. 100 mm is diameter. If you will do calculation, you will get the dimensions of this profile. Then X. What is X? X is 75 for P3 and Y is 175. 175. I am just giving the input and I am just pressing accept. See, again one problem will happen here. If you will press select this accept option again once more, so that time my cycle will get disappear. So we need to be very careful, and students are doing this mistake always. So if you are doing this mistake, don't be panic. You just press this right hand side of cursor button of screen button. This is the navigation key. Just press this right hand side key. If you will press this key, your screen again will get open. Okay, after that P3 to P4, I wanted to go P3 to P4. So what is this how it looks? P3 to P4 is horizontal line, is vertical line, is diagonal line, or it's arc? It's arc. So again I need to select this arc option. So again I will select what is the direction of arc, clockwise or anti-clockwise. This is again going clockwise direction. R is 50. What is X? X is 175. How much is Y? Y is 175. We are going for P4. So I will accept this. Point number 2. Then again point number 3. Again we are going from P4 to P5. I will select this fourth option. This is again arc. This I am again going for clockwise direction. R is 50. X is 175. It's very easy operation. And again what is the next line? That is Y. Y is 75. I am just giving these inputs and just pressing accept. It is a P5. Again I need to go from P5 to P6. So I will again press this. After P5 to P6, I will again press this option, and again I will select this clockwise. R is 50 mm. X is, what is X? X is 75. Y is again 75. So in this manner we just generated this type of profile for my pocket milling operation. It's a perfect profile. You just cross check this profile. If you get any problem, you just ask me in comment box. I will definitely try to give you solution on that. So after creating this profile, if you wanted to create any other type of the exercise options into this, you can also give. But this is a simple profile. I wanted to just, this is the first profile milling video, so that just I wanted to give you a simple type of the exercise. So don't be panic. It's very easy exercise. Just I am pressing a accept. Yeah. So after pressing accept button, I need to give depth of cut, speed, field, and other things. So for that, I need to select one another option. So there are many options. So my intention is that I need to create a profile pocket milling. So for creating profile pocket milling, I need to select this fourth option, that is a pocket. Fourth option. So I will press this fourth option. Once I will press this fourth option, that is a pocket milling, this type of screen will appear in front of you. In this screen, I need to give again my required input. So first is a incomplete. I will just keep it like this, only complete option. Second option is asking about cutter. Which cutter should I use? If I will go to cutter option, and if I will select this select tool option, this type of our offset page will appear in front of me. So I need to select the cutter which I wanted to use here. So before selecting that tool, we need to be very careful here, because for this profile there is no limitation of cutter diameter, because of definitely we will use 10, 12, 20 mm cutter diameter is also okay, fine. But again we need to be very careful at the time of selecting tool for pocket milling, because if you will select wrong tool, your pocket will not get generated. So that I'll always think that our tool diameter should be less than radius of the corner of pocket. So for this, particularly for this profile, we don't have that much amount of limitations. But when we will see about the corner pocket milling, that time we will discuss about this topic. So right now I will just select this 10 mm milling cutter. So you just be with 10 mm milling cutter. So I am just selecting this, and before selecting this tool, you should give all offset values to that tool. Tool offset must be there. Only after that you should use that tool. Otherwise, this will be a bigger trouble for you. So I will I will select this. Okay. Next option is F. F means speed. I wanted to give 1000 feet. I am just giving 1000 mm per minute. Speed is at 2000 rpm. See, again by mistake I just selected this accept button, and this way I just get out from this profile. So I wanted to again open this profile. I will place this right side key. So after giving rpm, I wanted to give roughing or finishing cycle option. So if you will press this first triangle, that will be roughing option. Second option will be wall base, roughing base. Third option will be wall finishing of wall, and fourth is the chamfer. So for this particular cycle, I wanted to use only roughing operation. In this roughing operation, all metal will get removed from my cycle, and after that I can, as per requirement, I can use wall finish or base finish. So first of all, I will select this roughing cycle. Never ever use directly finishing operation, otherwise you will go in bigger trouble. So Z0 is 0, starting point is 0 in 0 axis. Z1 up to what dimension, what is the total depth of my pocket? So my pocket depth is minus 15 mm. So I will just give minus 15. By default, sometime it's coming like a INC. So if it's coming INC, then you need to give 15 mm plus whatever the depth is there. But my recommendation is that always use this absolute form and always give in the form of negative, because if we are taking offset at the face of our workpiece, so that always gives the good selection for the absolute and incremental type of the option. Next is a DXY. By default it's coming mm, so never ever use this mm is like confusing for everybody. So always like just press this select option. After pressing select option, this will come in the form of percentage. So DXY is a step over, horizontal step over, that is we called as horizontal depth of cut also, but that is a step over. So I am just giving here 70% depth of cut. This is roughing, so 70% depth of cut is good. Yeah, if I will give less step over, my cycle time will get increased, and if I will give more step over, I will not get good surface finish also, and chatter mark will also get generate on my profile. DZ is a depth of cut. I am giving 1 mm depth of cut. UXY and UZ. UXY is a finishing allowance in X direction and Y direction, that is wall finishing allowance. If I wanted to create a finishing operation after this, so I need to give some allowance for finishing, so that is a UXY finishing allowance. UZ is a base allowance, base finishing allowance. That's it. Starting point, we should directly give this automatic. No need to think for this manual and all, because of if you will think this manual and all, that will be again like a bigger history for that. So that is sufficient for you to use this automatically option. Next option is that this is very important option. So always don't use bad option here, don't use any type of the wrong option here. If you will use wrong option, then machine will give lot of vibrations and machine will not give you that much amount of accuracy. So if you wanted to use vertical, this is the most favorite option people are using. This option is giving lot of vibration to machine at the time of insertion. So before using this option, you need to be drill a hole that diameter should be greater than your cutter diameter, which cutter you are using for pocketing. So then and then only your machine will not get that much amount of the vibration at the time of insertion inside the workpiece. Okay, great. So this is the vertical option, and if you are pressing this vertical option, you need to give some this is a feed for insertion feed, that is you need to be give 100, 1000, whatever you wanted to give. Always give 100, 200, that is more than sufficient if you are not pre-drilling a hole. And if you are pre-drilling a hole, then you can give more feedlet also at like 1000, 1000, 2000, whatever you wanted to give. Second option is that this is about helical option. This is the most safest option, and for aerospace, defense industries, this type of option they are like popularly using. So this is the helical option, and you need to give this type of EP and ER. These are the pitches of this helix. So I need to give this option. So 1 mm is more than sufficient. This is like a depth of cut, you can say, or insertion cut also you can say. This is the most like common sense. And third option is oscillator. This we are calling as ramping. This is the ramping option. So you can give here angle of ramps 10, 15. Sometimes people are using 2-3 degree. So that is like giving a good amount of the insertion, and we can say that vibration proof insertion. So as per requirement and as per the popularity, I am using this helical option. ER and EP 1 is more than sufficient for this MM option. Lift mode to RP. There are two options. After completion of this operation, my tool should go to retraction plane, which I given in my first cycle, or my tool should go to this Z0 plus safety distance. Always use this to RP option. After completion of my operation, my tool should go to RP option, that is the retraction plane. This is my total cycle. Look like this is a difficult, but not at all difficult as compared to creating a manual programming or G code program. This is the most easiest way of the programming language, and I'm just pressing here accept. You just think, if you are creating this program manually, how much line you need to be get generated, and here we are just creating this program in only 4 lines. That's it, our program get generated. So I will just simulate this program. How it will look, how it will appear. This is the beauty of this cycle. See, plane infield is too large, residual corners are remaining. This alarm is coming, and this alarm is intentionally coming. Okay, my intention was that alarm should be come. So every time you need to get the solution on this. So you need to learn how to do troubleshooting also. For this troubleshooting operation, option is DXY. So I need to give here 50 mm, 50%, 50% step over. Now see how it will work. I will accept it. Yeah, and I will simulation. See, now it will work. I am giving you this confidence. See, my tool is coming, and my tool is just appearing inside my workpiece, and this way my profile is getting generated. It's a very interesting topic. You just need to understand it, and if you will understand easily, you can also generate this type of cycle. See, again first path is completed, again moving for second path. See how it is take step over. See, this way how my tool path is working, you just understand. See, in this way my total depth get generated for pocket milling operation. See, this is my pocket milling operation. In this way we created this profile in my pocketing. It's interesting, right? It's very interesting. Yeah, again one more thing is that I will give you another lecture on this profile pocket milling. There I will give you solutions on corners, horizontal, diagonal lines. So another lecture we will see, and in that lecture we will again discuss more things, whatever the questions are coming from you. So in this way we just seen about this profile. So I will show you again a beauty of this. I will run this program, how it will work. So I will just run this program. Feed start, execute. See, sure, this is it. I'm just starting this program. This is the RPM start, cycle start. See, my program is running, and if I will press here basic block option, see, this is running like a CAM programming. How it is looking. This type of codes are getting generated by my machine in this shop milling programming cycle. So this is the beauty of this programming method, friends. So we should be very happy for learning to this, and we always go for this programming language. So this will be like a easiest solution for you. If you're using CAM, then you need to be pay for CAM and all. You need to learn CAM. This is a very easiest option, and like a CAM, 2D CAM, 2.5 axis CAM, these are giving you the solution. See how it is running. It's very easiest way. So in this way we learn about how to create a pocket milling, profile pocket milling cycle in shop milling programming method. So if you are new on my channel, kindly subscribe to my channel. If you will subscribe to my channel, I will get motivation from you, and on the basis of that motivation I will again try to give you this type of the beautiful solutions. So on the basis of that solution you will also get enlightened, and we will learn together. Okay, thank you so much. Thanks a lot.